How Christmas lights are manufactured. The shocking truth behind your holiday glow. Picture this. You're untangling a massive ball of Christmas lights. We've all been there. Cursing under your breath when suddenly you wonder, who made this infuriating mess? How did these tiny glowing bulbs even come to exist? And why do they always tangle into an impossible knot? Hold on to your Santa hat, because the story of how Christmas lights are manufactured is absolutely bonkers. We're talking about a journey from molten glass blowing to assembly lines where workers connect 25,000 bulbs per shift from deadly early experiments. Yes, people died for your festive glow. To factories where the air literally sparkles with glass dust. Here's a stat that'll light up your brain. Over 150 million strings of Christmas lights are sold in the United States every year. That's roughly 35 billion individual bulbs. If you laid them end to end, they'd circle the Earth 150 times. And almost every single one starts its life in the same region of China, where workers you'll never meet spend their days creating the magic that makes your house look like Clark Griswold's mansion. But the real kicker? The technology that lights up your tree is basically unchanged from the 1890s, yet somehow got 99% cheaper and 1,000% safer. Buckle up, because we're about to illuminate one of the most fascinating manufacturing stories on the planet. The deadly beginning, when Christmas lights could kill you. Let's start with the fact that early Christmas lights were basically tiny bombs hanging on your tree. In 1882, Edward H. Johnson, an associate of Thomas Edison, created the first string of electric Christmas lights. His tree had 80 hand-wired red, white, and blue bulbs that cost the equivalent of $2,000 in today's money. That's $25 per bulb. For context, you can now buy 100 bulbs for $5 at Walmart. Capitalism is wild. But here's the terrifying part. Early Christmas lights used open flames or incredibly hot, incandescent bulbs that could reach 300 kilowatts, 150. Houses regularly caught fire. People were electrocuted. Insurance companies literally tried to ban them. One newspaper in 1895 called them a menace to life and property. The bulbs were hand-blown glass filled with a vacuum to prevent the filament from burning up, and they frequently exploded. Imagine tiny glass grenades on your tree, shattering randomly and raining shards on your presents. Merry Christmas! Here's a trip to the emergency room. It took until the 1920s for someone to invent the safety fuse, and even then, entire strings would go dark if one bulb died. More on that infuriating feature later. The Chinese light bulb capital, Yiwu, strikes again. Remember Yiwu, the city that makes 60% of the world's Christmas decorations? Well, surprise! They're also responsible for about 80% of the world's Christmas lights. But the real manufacturing hub for Christmas lights is actually the neighboring city of Taizhou, specifically in the Zhejiang province. This region has over 1,000 factories dedicated to producing Christmas lights and decorative lighting. It's an entire economy built on making your house twinkle. Here's what's absolutely insane. These factories operate year-round, but during peak season, July-October, preparing for the Christmas rush, workers pull 12 16-hour shifts, 6 to 7 days a week. A single factory can produce 10 million bulbs per day. That's 115 bulbs per second, 24 hours a day. Walk into one of these factories, and it's surreal. The sound is deafening, machinery clanking, glass tinkling, workers shouting over the noise. The air shimmers with heat from the glass-blowing stations, and everywhere you look, lights. Billions of lights in every color, half-assembled, being tested, coiled into boxes. One factory worker said in an interview, "I make Christmas lights all year, but I've never had a Christmas tree. We don't celebrate it here, but I'm happy knowing families around the world use what we make." That quote hits different, doesn't it? The glass-blowing process. Liquid glass becomes magic. Now let's get into the nitty-gritty of how these little glass bulbs are actually made, because it's part medieval alchemy, part modern robotics. Step 1, the glass recipe. Christmas light bulbs start as raw silica sand mixed with sodium carbonate, limestone, and various other minerals. Different colors require different additives. Cobalt oxide, blue, copper compounds. Green, gold chloride, red, yes, actual gold. Selenium, yellow, orange, manganese dioxide, purple. The most expensive bulbs? Red ones, because gold is pricey even in trace amounts. But most modern colored bulbs skip this expensive process and just paint clear bulbs instead. We'll get to that scam in a minute. Step 2, the blowing station. Here's where it gets mesmerizing. The liquid glass is fed into automated glass-blowing machines that work like robotic lungs. A metal rod dips into the molten glass, picks up a blob, called a gob in industry terms, and then compressed air literally blows it into a bulb shape inside a mold. The process takes 3 seconds per bulb. The machine can run continuously, producing 20 bulbs per minute per station. A large factory might have 100+ blowing stations running simultaneously. The temperature has to be perfect. Too hot, and the glass is too thin and fragile. Too cold, and it won't blow properly. The tolerance is about 10 degrees, insanely precise for molten glass. Step 3. The annealing oven. Fresh glass bulbs are stressed and brittle. They need to be gradually cooled in an annealing oven that slowly drops the temperature over 3 to 4 hours. Skip this step, and the bulbs shatter randomly weeks or months later, usually right after you've strung them up on your tree. This is why cheap lights randomly explode. They skip proper annealing to save money. The bulbs travel through a tunnel oven on a conveyor belt like a glass car wash. It's actually quite beautiful. Thousands of glowing bulbs slowly cooling from orange to clear. The filament, tungsten wire, thinner than hair. While the glass is cooling, another part of the factory is making filaments. This is precision engineering at its finest. Christmas light filaments are made from tungsten wire that's typically 0.01 at 0.0 cm thick, thinner than a human hair. For comparison, a human hair is about 0.0 cm. This tungsten wire is coiled into a tiny spring to increase surface area and brightness, using machines that look like they belong in a watchmaker's workshop. The process? 1. Pull tungsten wire through progressively smaller dies. 2. Coil it around a mandrel, like wrapping thread around a needle. Heat treat it to set the coil shape. Cut to precise lengths, usually 25 to 30 mm for standard bulbs. A single machine can produce 50,000 filaments per hour. The precision is bonkers. If one filament is 0.1 mm too long or short, that bulb might burn out faster or glow dimmer than its neighbors. The assembly line, where humans and robots dance. Now comes the most labor-intensive part, putting it all together. Despite heavy automation, Christmas lights still require a surprising amount of human hands. Station 1. Filament installation. Workers, usually women, as they're considered to have more nimble fingers. Yes, that's the actual industry reasoning. Grab tiny filaments with tweezers and feed them into the glass bulbs. Support wires are added to keep the filament stable. This requires incredible precision. We're talking millimeters of accuracy, repeated 1,000 plus times per shift. Some modern factories use robotic arms for this, but many still rely on human workers because robots struggle with the delicacy required. One mistake, and the filament touches the glass when it heats up, causing the bulb to fail. Inside this base, the filament wires are connected to 2 metal contacts that will eventually connect to the electrical current. They're clear glass bulbs that are spray-painted or dip-coated with translucent colored lacquer. Why? Because it's 10 times cheaper than actually coloring the glass during manufacturing. A bottle of paint costs $20 and can color 10,000 bulbs. Colored glass requires expensive additives and specialized processes. You can spot the difference. Real colored glass glows evenly and beautifully. Painted bulbs have slight variations, and the color sometimes chips off over time. Ever notice your red bulbs looking pink after a few years? Premium lights still use colored glass, but anything under $15 for a 100 bulb string, that's painted glass, guaranteed. Station 4, vacuum sealing and gas fill. Modern Christmas lights aren't pure vacuum like old bulbs. They're filled with inert gases, usually nitrogen or argon, which prevent the tungsten filament from oxidizing and burning out quickly. The bulb is placed in a vacuum chamber, air is sucked out, inert gas is pumped in, and the base is sealed. This happens in about 2 seconds per bulb. The seal has to be perfect, any tiny leak, and the bulb dies within days. The series circuit conspiracy. Why one bad bulb ruins everything. Time to address the elephant in the room. Why does the entire string go dark when one bulb dies? It's because Christmas lights use a series circuit. All the bulbs are connected in a chain, and electricity flows through each one sequentially. When one breaks, the circuit breaks, and the whole string dies. But wait, you say. Modern lights stay on even when one bulb is out. Ah, clever consumer, let me introduce you to the shunt, a tiny piece of wire inside each bulb that acts as a backup pathway. When a filament breaks, the heat causes the shunt to activate, allowing electricity to bypass the dead bulb and keep the rest lit. It's ingenious. Until 3 to 4 bulbs die, then the remaining bulbs have to carry more voltage, causing them to burn brighter and hotter, which makes them die faster, creating a cascade failure. It's planned obsolescence disguised as a feature. LED lights, the revolution that changed everything. In the early 2000s, LED, light-emitting diode. Christmas lights hit the market and changed the game completely. LEDs are made from semiconductor materials, silicon carbide, gallium nitride, rather than glass bulbs and filaments. The manufacturing process is completely different. Wafer production. Silicon wafers are grown in clean rooms, like computer chips. Doping, adding impurities to create p-n junctions that emit light cutting. Wafers are cut into thousands of tiny LED chips. Mounting. Chips are mounted on metal leads. Encapsulation. Clear epoxy resin is poured over the chip to protect it and focus. The light LEDs use 90% less electricity than incandescent bulbs, last 25 times longer, 50,000 plus hours versus 2,000 hours, and stay cool to the touch. They're also more expensive to manufacture, which is why LED strings cost 3-5 times more than traditional lights. But here's the fascinating part. LED Christmas lights are mostly manufactured in South Korea and Taiwan rather than China, because making semiconductors requires more advanced technology and clean room facilities. China is catching up fast, but for now, your LED lights probably have a more international journey than incandescent ones. The testing gauntlet. 25 ways to murder a light bulb. Before lights leave the factory, they go through intense quality control testing that would make a military boot camp look gentle. The burn-in test. Strings are powered on for 48 to 72 continuous hours at higher than normal voltage to weed out weak bulbs. Any that fail are pulled and recycled. The drop test. Strings are dropped from 6 feet onto concrete to ensure bulbs don't shatter on impact. Premium brands require bulbs to survive 3 drops. Cheap brands skip this entirely. The water test. Lights are submerged in water while powered on with safety precautions to test for shorts and verify they meet safety standards for outdoor use. The pull test. Each wire connection is pulled with 10 to 15 pounds of force to ensure it won't disconnect during shipping or use. The flash test. Every single bulb is tested by running current through it to verify it lights up. Automated cameras scan for dead bulbs at a rate of 100 strings per minute. Factories producing for major American brands, GE, Philips, etc., have rejection rates of 2-3%. Cheap knockoff factories try 15-20% defect rates, but they ship them anyway because most consumers won't return a $5 string of lights. The wire wrapping, why your lights always tangle. Ever wonder why Christmas lights tangle into impossible knots? It's actually partly intentional. The wire used is called SPT1 or SPT2 wire, stranded parallel thermoplastic. It's deliberately flexible to allow wrapping around trees and houses, but this same flexibility makes it prone to tangling. In the factory, lights are machine wrapped around cardboard spools or folded into figure-8 patterns. But during shipping, boxes get jostled, stacked, compressed, and dropped. The flexible wire shifts and intertwines with itself. Some premium brands use twist tie organizers or plastic reels, but most don't because it adds $0.51 to the cost. That's the difference between profit and loss in the cutthroat Christmas light market. Pro tip from factory engineers. The figure-8 wrapping method, over-under, is actually the best way to prevent tangling. But hand wrapping 25-foot strings takes time, so most manufacturers just coil them randomly and hope for the best. The economics: a $6 billion global industry. The worldwide Christmas lighting market is worth approximately $615 billion annually. To put that in perspective, that's more than the GDP of Belize, or enough to buy 750 million Starbucks lattes. Cost breakdown for a $10 string of 100 incandescent lights. Materials: glass, wire, copper. $1.50. Labor, assembly, testing. 1.0. Packaging, 0.30. Factory overhead, 0.70. Shipping from China, 1.50. Importer markup, 2.0. Retailer markup, 3.0. So, that $10 string cost about $5 to make and ship. The lights you see at dollar stores, they probably cost $1 to $2 total, with corners cut on safety testing, wire gauge, and bulb quality. The environmental nightmare. Here's the dark side. Christmas lights are an environmental disaster. Americans use approximately 6.6 billion kilowatt hours of electricity for Christmas lights each year, enough to power 14 million refrigerators. The carbon footprint is equivalent to 690,000 cars driven for a year. Worse, incandescent bulbs contain tungsten and small amounts of lead in the base solder. When thrown away, which happens to 150 million strings annually in the US alone, these end up in landfills where the lead can leach into groundwater. LED lights are better, but still contain semiconductor materials, rare earth elements, and aren't easily recyclable because they're mixed with plastic, metal, and glass in complex assemblies. Only about 2% of Christmas lights are recycled. Most people just throw them in the trash. The future: smart lights and app control. The Christmas light industry is going high-tech. Addressable LED lights. Each bulb can be individually controlled by a microcontroller, allowing for animations, color changing, and synchronization with music. These require tiny computer chips in each bulb. Basically, your Christmas lights have more computing power than the Apollo 11 spacecraft. No outlet needed. Projection lights. Skip the hanging entirely. Just project light patterns onto your house with specialized LED projectors. Smart home integration. Lights that work with Alexa, Google Home, and sync with your music, doorbell, or even your mood. There are lights that connect to fitness trackers and change color based on your heart rate. Creepy or cool? The verdict. So there you have it. Your simple string of Christmas lights represents molten glass, blown by robots, tungsten wire, thinner than hair. Assembly lines where workers connect thousands of bulbs per shift, and a global supply chain spanning multiple continents. That $8 string of lights at Target? It's been touched by at least 20 human hands, traveled 7,000 miles, survived quality testing that would destroy lesser bulbs, and represents technology that's evolved over 140 years from literal death traps to safe, efficient, beautiful illumination. Next time you plug in your Christmas lights, remember, each tiny bulb is a miracle of modern manufacturing. And yes, they'll still tangle into an impossible knot, but at least now you know why. Happy illuminating from all the workers in Taizhou and Yiwu who spend their entire year making sure your holidays glow, even though they have never hung a single strand on their own homes.